Hello everyone and welcome to this next session of the CCNA online training program. Now before we continue with today's topic, okay, in fact we are going to continue with the same module, that is building a simple network. But before we start off with today's session, I would like to do a quick review of the topics that we covered in the previous session. Okay, so mostly yesterday what we did was we spent most of our time learning about some basic configurations on a Cisco switch. You know, we talked about some basic Cisco commands, okay, wherein we talked about or learned about how to configure a host name on a switch. We also talked about how to configure an IP address, okay, and a subnet mask on an interface. We also learned about how to enable the interface. We also talked about how to configure a default gateway for a switch. Okay, the next command that we learned about was some show commands, some commands that were related to verifying the configuration that we did. Okay, we also reviewed some of the previous commands that we learned with regards to saving the configs and so on. And then what we did was we started off with working on the LAN or understanding LAN. Okay, so under that we talked about the different types of communication that can happen within the LAN, like the screen that you can see right now. Okay, we talked about unicast communication, wherein unicast means one-to-one communication. Then we have broadcast communication, that is one to all. Okay, and then we have multicast, that is one to a group. Okay, so that is what is multicast. So these are the different things that we talked about in our previous session. Now today's agenda, if I talk about it, we are going to continue with the same module, wherein we are going to go deeper into understanding Ethernet. And then what we are going to do is at the end of this particular module, we are going to do some lab, okay, related to whatever we have learned until now. Okay, now getting along, do you have any questions at this point of time so that you can come up, and once we take care of that, then we can continue. Okay, so let's go ahead then. Now the next thing that we are going to talk about today is about MAC address. Okay, now what is a MAC address? Every computer or every device, when I talk about it, if it has to communicate on the LAN, okay, so every device, if it needs to communicate on the LAN, okay, it needs to have a network interface card, right, or an NIC, or it needs to have a network adapter. It is using the network adapter, okay, and then using the appropriate network media that the device can be plugged in into a switch, okay, and then it would be able to communicate with other devices. Okay, so for a device to communicate on the LAN, what do we need to do? We need to take that device, like let's say the device is a laptop, so we need to take that device, okay, connect a media, a cable, network cable to the network card of that laptop, and then the other end of the cable will go into the switch, right? And then based on that, based on the IP address that we have configured on the machine starts communicating. But how is that possible? How does the machine know about IP addresses, and how does it go ahead? Okay, so for doing that, every network card or network interface card, when we talk about it, every network adapter, when we talk about it, it has a unique address that is hard coded into it. Okay, so every LAN card or every network adapter has a unique address that is hard coded into it. Okay, so what is this unique address that is hard coded or burnt into the chip of the machine of the LAN card? Okay, that address is nothing but the MAC address. Okay, so what is a MAC address? MAC address, in simpler terms, is the physical address of a network adapter. You understand that? Okay, MAC address is the physical address of a network adapter. Okay, it is always going to be unique. Okay, so every network adapter will have its own MAC address. But when I talk about this MAC address, okay, this MAC address is actually this MAC, when I talk about it, this MAC address is nothing but media access control address. Okay, let me just write it down for you. Okay, so this MAC is nothing but media. I'll just change the color. Okay. Okay, so MAC is nothing but media access control. Okay, so that is what it is, media access control. Now this media access control is nothing but a value that is represented with regards to layer 2. Okay, I hope you remember the layer 2 of the OSI model, the data link layer. Okay, so this MAC address is an address that is specified with regards to layer 2. Do you understand? Okay, and when I talk about an IP address, it is an address that is specified with regards to layer 3. Okay, so understand the difference. MAC address or media access control address is an address that is specified with regards to layer 2, and IP address is an address that is specified with regards to layer 3. Okay, now let's talk about the MAC address itself. Okay, so whenever we talk about the MAC address typically is of 48-bit. Okay, like yesterday we talked about bits, right? Okay, so MAC address typically is of 48 bits. Okay, and it's represented in the form of a 12-digit hexadecimal value. Okay, so when I talk about a MAC address is ideally of 48 bit. Okay, but these 48 bits, okay, are represented in the form of a 12-digit hexadecimal value. Okay, now what? Let's try to understand this concept of a hexadecimal value. Okay, now for understanding this concept of the hexadecimal value, okay, take a look at this. A hexadecimal value typically would range, or a single hexadecimal digit ranges between, okay, 0 to 9, okay, and then A to F. Okay, so that is how a hexadecimal digit will look like. Okay, it will range between 0 through 9 and then A to F. Okay, so typically that's the hexadecimal value. Okay, so a hexadecimal value will start with 0, that is 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and after that it will start off with A, B, C, D, E, and then F. Okay, so these are the values that we have, and every digit when I talk about it is equal to 4 bits. Okay, every digit when I talk about it is equivalent to its appropriate bits. Okay, that is 4 bits. Do you understand? Okay, so bottom line is, if I talk about a hexadecimal value, okay, of 0, okay, if I talk about a hexadecimal value of 0 in bits, if I want to represent it, it will be 0000. Okay, now we'll talk more about these hexadecimal values and all of that when we do or talk about IP addressing as well. Okay, there we are going to get into details about hexadecimal, binary, bits, or decimal value and all of that. Okay, so there things would be much more clearer, but that's the way it is represented. So effectively, when I talk about 48 bits, okay, each 4-bit section represents one hexadecimal digit. That's the reason it turns out to be a 12-digit hexadecimal value. Okay, so 12 into 4, that becomes 48. Okay, so that's how you get the 48 bits. But ideally, it is represented in the form of a hexadecimal value. You understand that? Okay. So saying that, when I talk about this MAC address, okay, the MAC address, as I mentioned, it is of 48 bit, but out of the 48 bits, the first bit, okay, represents the broadcast. Okay, the first bit, okay, remember this is the bit we are talking about. It is not a hexadecimal digit we are talking about. We are talking about the first bit. So the first bit would represent broadcast. Okay, the second bit also, okay, is a different value, that is local. Okay, then we have the rest of the 22 bits called as OUI. that is organizational unit identifier. Okay, let me repeat that again. The rest of the 22 bits that you see here, these 22 bits represent the organizational unit identifier. Okay, so we have the first bit that is broadcast, second bit that is local, and then the next 22 bits is organizational unit identifier. This is going to be a fixed value which represents the organization or the manufacturer for that network card. Do you understand that? Okay, it represents a value, a fixed value that is related to the manufacturer's ID. You understand? That is what is nothing but organizational unit identifier. And then we have 24 bits, the remaining 24 bits, that is nothing but a vendor assigned value. Okay, for each and every individual network card, the vendor is going to assign a separate number. That is the 24 bits. Okay, so effectively when I talk about the 48 bits, the first bit is the broadcast, second bit is the local, then we have 22 bits which are represented by organizational unit identifier, which is unique for a manufacturer, and then we have a vendor assigned number, that is the last 24 bits. Are you clear about this concept here about a MAC address now? Okay, so this is what you would typically have with regards to a MAC address. Okay, now let me show you how to look at the MAC address of a computer. On a computer, okay, if I want to have a look at the MAC address, okay, I need to typically go into the command prompt of a computer. Okay, in fact, let me go into packet tracer because most of the labs we are going to do it on packet tracer. So I'll show you how to look at the IP address or how to look at the MAC address of a computer in packet tracer. Okay, so let me just open it up and then I'll show it to you. Okay, so my packet tracer is now open. Okay, out here what I'm going to do is I'm just going to add an end device. Okay, and then what I'm going to do is I'm going to take a switch. Okay, now yesterday we talked about taking a laptop and connecting the switch via console, right? That's what we talked about yesterday. But today what I'm going to talk about is this PC would be connected to the switch via a different type of a cable, that is the copper cable. Okay, in fact we talked about copper and fiber cable, but when I talk about the switch only supports copper connection. Okay, this switch does not support fiber, so hence we are going to connect a copper cable. Now when I talk about a copper cable, there are two types of copper cable available. One is a copper straight through, okay, and then the other one is a copper crossover. Now we'll talk more about this copper straight through and copper crossover a little later, but right now what I'm going to do is I'm going to take the copper straight through and connect this PC on fast Ethernet 0, and at the other end I'm going to plug it into the first port of the switch. Okay, so that's what I'm going to do just for this particular example of looking at the MAC address. Okay, now once I've done that, I'm going to double click on this computer here. Okay, and then click on desktop. Now when I click on desktop, I get the option of command prompt. Do you see that? Okay, so when I click on command prompt, this is what is going to come up. Okay, and in this command prompt, the command that I need to type, okay, to know about the network card is ipconfig. Okay, so remember this command. When you go into your Windows machine and open up the command prompt, you have to type in ipconfig. Okay, so when you type ipconfig, okay, what it's going to basically tell you about is it's going to tell you that you are using fast Ethernet 0. Okay, apart from that, it will give you information about what is the IP address configured on this machine, the subnet mask that is configured, default gateway that is configured, and it will also tell you an IP version 6 address if at all is configured. Okay, so bottom line is it's going to give you all these details, but ipconfig command can also be used to look at the MAC address of a network card. Okay, the ipconfig command can also be used to look at the MAC address of the network card. I told you every network card has its own MAC address, right? So I can use the same ipconfig command to have a look at the MAC address as well. How do we do that? To do that, the command that I'm supposed to run is ipconfig space /all. Okay, so remember this command. On a machine, if you want to look at the MAC address of the machine, you have to type in ipconfig, but after ipconfig you have to put up a space / and then all. You understand? When you do that and press enter, there you go. What do you see? You see the physical address. Okay, as I told you earlier, physical address is nothing but the MAC address, and that is what it shows you here. Okay, so as you see, that is the MAC address, which is of 12 digits. Okay, 4, 4 and 4, that becomes 12. Okay, but remember these values are hexadecimal values. Okay, so that is the 12-digit MAC address. Do you understand that? Okay, so on a machine, if you want to have a look at the MAC address, you have to type in ipconfig /all. Are you clear about these two commands, ipconfig and ipconfig /all? Okay, great. Okay, now this was on a machine if I want to have a look at the MAC address. Now, when I talk about a switch, even the switch has a lot of ports on it, right? So ports means nothing but it is a network card or a network interface. So which means since it's a network interface, it will have or it will also have its own MAC address. Okay, so to have a look at the MAC address, okay, what you need to do is you need to get into the command line of the switch. Okay, let me take you to the command line of the switch. Okay, now that's the command line that we have, and to have a look at the MAC address of the switch, the command that you need to make use of is show interfaces. I hope you remember this command. Okay, so the show interfaces command gave you the status of each and every individual interface. Okay, so when I run that, what do you see? It's telling me about fast Ethernet 0/1, and look at this hardware, and then look at this address is, and then it's giving you the address. This address is nothing but the MAC address. You understand that? So even on a switch, or even if you go into the router, you would be able to see the MAC address in this manner. Show interfaces. Okay, that is what you can use, or you can also type show interfaces fast Ethernet 0/1. You can specifically type the name of the interface, and it will give you details about that particular interface. Okay, now one other thing that you would notice out here is it says address is this one, and then in round brackets it also tells you BIA, and it gives you the same value again. Okay, so this BIA which you see here, the BIA, okay, is nothing but burnt in address. Okay, that's nothing but the physical address. Okay, since it's hard coded, it's also called as burnt in address. Okay, so that is the BIA. So you have the flexibility of changing the MAC address of a network card. So if you are changing the MAC address, the burnt in address is going to remain the actual one, but this address which you see before that is going to be the changed one. Okay, so if you happen to change the IP address on the interface, okay, so if you change the MAC address on the interface, the changed MAC address would be visible here, but then the original MAC address would be shown as BIA. Do you understand that now? Clear about that? Okay, when it comes to MAC address. So remember, when I talk about the MAC address, it is called as physical address, or it can also be called as burnt in address. Are you clear about the concept here? Okay, great. So let's go ahead. So that is how you can have a look at the MAC address. Okay, now let's go ahead. So that's a typical representation of the MAC address. But if I talk about this MAC address, as I told you before, this MAC address is represented in hexadecimal digits. Okay, which means each of these digits represent 4 bits. Okay, so if you notice here, the first bit is the broadcast. So if I talk about the first bit, typically it's going to be something like this. Let me just quickly show that to you in writing. Okay, so typically this MAC address in bits, if I want to type it, the first 0 would be represented as 0 0 0 0. The second 0 again would be represented as 0 0 0 0. Okay, so that is how I would represent this first section here. Okay, now out of this first section, this first bit that is 0, let me just stop it and just a minute. Yeah, so if I represent the first bit here, this first bit would be the broadcast. Okay, the second bit that you see here would be the local. Okay, and then the remaining 22 bits would be the OUI, and the last 24 bits would be the vendor assigned value. You understand that? Okay, so that is how it would be represented internally. But overall, this is how you would look at a MAC address. Okay, or this is how the MAC address would be represented. Okay. So that was about MAC addresses. But now let's talk about the operation of a switch. Okay, let's talk about what will happen when a machine is going to send in some information into the switch, and what is the switch then going to do about it. Let's talk about all of that. Okay, so when it comes to that, okay, what's going to happen is, okay, let me just show you something here. I'll just go back, take you back into packet tracer. Okay, now in packet tracer, this is a connection that we have, or this is how it's connected, right? Let me show you something here. I'll just remove this connection here. Okay, so I deleted the connection. Okay, and then what I'm going to do is, okay, what I'm going to show you is, I'm going to take this cable here, connect it to the switch port at one end, and at the other end I'm going to connect it to the machine. Okay, so at this point, if you look at the machine here, the link, it shows that it's down. Okay, do you see that part here? The link column shows that it's down because there is no cable plugged in into that. Okay, but the moment I plug in the cable, look at the light status. Okay, see, the moment I plug in, this light shows green, but here the light shows amber or orange. Do you see that? The light side on the switch side shows that it is orange or amber, but on the machine side or the PC side, it shows that it's green. Okay, now what is happening here? Out here, the moment you connect any device, like it's not necessary that you need to connect a machine, but even if you connect a PC or even if you connect a router or any other device, the first thing that the switch is going to do is, it's going to try to learn the MAC address of the machine. Okay, the switch is going to try to learn the MAC address of the machine, and once it has learned the MAC address of the machine, that's when you would find that this light turns green. Okay, so until that point of time, the light would be amber or orange. Do you understand? Remember that on the switch side, the light initially is going to be orange or amber, and once it learns the MAC address of the machine, then it's going to turn green. Do you understand that? Clear about that now? Okay. Yeah, but now let's try to understand, how does this switch learn about the MAC address of the machine. Okay, let's talk about that. So for the switch to learn about the MAC address of the machine, this machine sends out a frame into the switch. Okay, a machine typically sends out a frame into the switch. Okay, now what is that frame about? That frame is nothing but the Ethernet frame. Do you remember the Ethernet frame structure that we talked about in the previous session? Okay, so if you remember the Ethernet frame structure that we talked about in the previous session, you'll also remember that whenever I talk about the Ethernet frame, okay, let me just quickly show that to you or show that part to you. I think it was a bit behind. No, it was not this way behind. I think we talked about the frame yesterday only, right? Ethernet frame. Yeah, it was here somewhere, so it will come up in a while. Yeah, there you go. So if you look at this Ethernet frame structure, you'd find that there are two fields there. One is destination address and the other one is source address. Now what is this source address and destination address? This source address and destination address are nothing but the MAC address. Remember that. Okay, so they are talking about the source MAC address and the destination MAC address. Okay, they are going to talk about the source MAC address and the destination MAC address. Did you see that? Oh, okay, okay. So you're not able to see that, is it? Okay, let me just show that to you again. Let me take you back. Yeah. So are you able to see the screen now? Oh, okay, okay. Now you're able to see it, right? Yeah. So if you look at the screen right now, okay, so there is this two fields here, source address and destination address. Okay, so this source address and destination address is nothing but the source MAC address and the destination MAC address. Do you understand? Okay. Now, typically when I talk about a Windows machine, okay, when I talk about a Windows machine typically has a protocol running inside it known as NetBIOS. Okay, within the Windows machine there is a protocol that is running called as NetBIOS. Okay, now what does this NetBIOS do? This NetBIOS, okay, constantly sends out broadcast packets onto the network. Okay, so what does the NetBIOS protocol do? The NetBIOS protocol constantly sends out broadcast. I hope you understand what is broadcast. We talked about broadcast in the previous session, right? Okay, so it's going to constantly send out which portion are you talking about? Yeah, that's what I mean. NetBIOS, well, you're not expected to know about NetBIOS at this point. I'm explaining it to you, in fact. Okay, so don't worry, I'm explaining it to you right now. Okay, I was actually explaining it to you. That's when you had this question. Okay, so basically NetBIOS, when I talk about it, okay, it is found on Windows machine. Okay, so what this NetBIOS protocol does is it constantly keeps on sending out broadcast. Okay, like in our previous session we talked about broadcast, right? Broadcast is like a one-to-all communication, right? That is what is broadcast. So this NetBIOS broadcast, when I talk about it, it allows a Windows machine to detect other Windows machines on the network. Okay, so what is this purpose of NetBIOS broadcast? The purpose of the NetBIOS broadcast is to detect other Windows machines on the LAN. Do you understand? Okay, so for that purpose, whenever we talk about a Windows machine, as soon as it is plugged in into a switch, it's going to constantly send out broadcast. Okay, and this broadcast is going to enter into the switch like a frame, because a switch is a layer 2 device, right? Yesterday I mentioned it. So switch, when I talk about it, it is a layer 2 device. So naturally the layer 2 device can only accept a frame. Okay, and what will the frame contain? The frame will typically contain source MAC address and the destination MAC address. Okay, so in that case, in this example, like let's say that machine is PCA. So when I talk about PCA, when it sends out that frame inside the switch, it will have a source MAC address and a destination MAC address. Okay, so when I say that, the source MAC address would be PCA's own MAC address. Okay, PCA has a network card, right? So PCA's network card MAC address will be the source MAC address. Okay, so if I am PCA and if you are PCB, in that case I am sending out a frame, let's say, okay, with source of mine and destination of yours. So source MAC address, that would be my MAC address, and destination MAC address would be your MAC address. Do you understand that? In a similar manner here, when PCA is sending out a frame inside the switch, it will have a source MAC address and a destination MAC address inside that frame. Okay, so that frame, as soon as it enters into the switch, what is it going to do? The switch is going to fill up the source MAC address, or it will take up the source MAC address and put it into the MAC address table. Do you remember the show MAC address table command? Like in our previous session, okay, I was explaining you about the show MAC address table command, and when I was explaining that to you, I showed you that when I ran the show MAC address table command, it was all empty. That was because no devices were connected to the switch, right? There were no devices connected to the switch. But now, in today's example, if you look at the packet tracer, okay, we have a PC plugged in into the switch. Now, in that case, if I go into the switch right now, okay, if I go into the command line interface of the switch here, and if I type enable and type in show MAC address table, when I do that, what is happening here? Till now, again, it has not learned any MAC addresses at all, right? Okay, it is yet to learn a MAC address. That's because this PC at this point of time has not sent any frame into the switch. The moment this PC sends out a frame into the switch, what is the switch going to do? It's going to take a look at the source MAC address, and what it's going to do is it's going to take a look at the source MAC address, and it's also going to look at where that frame has come in into the switch from, or on which port has it received the frame. Let me take you back into the diagram. Okay, so here this PC is connected to port number 1 of the switch. So the switch is going to look at where the frame was received. So the frame was received on port number 1. So immediately what the switch does is it is going to populate the MAC address table by typing in port 1, and then it is going to take a look at the source MAC address, or it's going to update it with the source MAC address of PCA, or it's going to update it with the MAC address of PCA. Do you understand that? Okay, so the first step that the switch does is the moment a PC is plugged in into a switch, and the moment there is a frame sent by the PC, okay, the switch is going to look at the frame and it's going to look at which port the frame entered into the switch. And then what it's going to do is it's going to take a look at the source MAC address and it's going to update the MAC address table. Okay, so it's going to look at the port, and in front of the port is going to put up the source MAC address information. So in this case, it's going to put port 1 and it has a MAC address of PCA because that is the source MAC address. Do you understand this portion until now? Okay, great. Okay, so that is the initial part. Okay, the next thing that the switch is going to do is, okay, the switch is going to then look at the destination MAC address. Okay, so initially what it did was it looked at the source MAC address and it updated the MAC address table. That's what it did, right? Then it's going to have a look at the destination MAC address. Okay, so it's going to have a look at the destination MAC address and it's going to search for the destination MAC address in the MAC address table. But as you know, right now the switch is all empty because we just have started with the communication, or the switch was powered on just now, which means there are no MAC addresses or there were no frames entered, because of which the MAC address table is absolutely empty. Okay, so what the switch is then going to do is it's going to send out something known as an unknown unicast. Okay, let me just write it down for you. So it's going to take a look at the destination MAC address, and if it doesn't find the destination MAC address in the MAC address table, it's going to send out unknown unicast. Okay, now what is this unknown unicast? Unknown unicast means it's going to check for that destination MAC address on each and every other port. Like in this example, the frame entered on port number 1, right? Okay, so what it's going to do is the switch is going to take a look at the destination MAC address in the frame, and then it's going to send it out via port 2 as well as port 3 and check whether it has the frame or it has the MAC address, or whether the devices connected to those ports have the MAC address. That is what is going to check, and that is what is shown out here. Okay, so the frame would be sent out on each of the other ports, and it's going to check whether it has the appropriate MAC address that is needed. Okay, now in this case, the machine on port number 3 has the appropriate MAC address. So what it's going to do is it's going to reply back to the frame saying that I have the MAC address. You know, the switch is going to ask a question, right? Do you have this MAC address? And then the machine is going to reply back saying that I have the MAC address. And the moment the reply comes back into the switch is going to look at the source MAC address again and is going to update the MAC address table. So now you find port number 3 has the MAC address of this particular PC. Do you understand that? Okay. So similarly, over a period of time, as and when it goes on ahead with this, okay, over a period of time you'll find against each and every port you would find the corresponding MAC addresses of the devices that are plugged in. Okay, so that is what you would typically find. Okay, and that is how the switch will update the MAC address table. Do you understand that now? Okay, understood the entire process of how the MAC address table is built up? Okay, great. Okay, so whenever I talk about a switch, what the switch does is it will always look at the frame, it will look at the source MAC address, and then it will look at the corresponding port where the frame was received, and then it's going to immediately update the MAC address table. Then what it's going to do is it's going to take a look at the destination MAC address and again check for the destination MAC address inside the MAC address table. So if it finds that the MAC address is already there, it's going to directly forward that frame across to that particular port. But if it does not find the frame, what is it going to do? If it does not find the MAC address, what is it going to do? It's going to send out an unknown unicast across all the other ports and check for the MAC address. Once it finds the MAC address, based on the reply, it's going to update the MAC address table with the corresponding port number. You understand? So over a period of time, when the frames go in and go out of the switch, you would notice that the MAC address table is now up to date. Okay, so that is what happens here. You understand that? Okay. Okay. Now let's talk about the next form of term related to LAN, that is duplex. Okay, so whenever we talk about communication on a LAN, okay, we also need to talk about duplex communication. Okay, now with regards to duplex, whenever we talk about Ethernet, Ethernet works on a concept of CSMA CD. Okay, so whenever we talk about Ethernet, Ethernet works on the concept of CSMA CD. Now what is this CSMA CD? CSMA CD, okay, is nothing but carrier sends multiple access collision detect. Okay, so this is what is CSMA CD. Okay, that is carrier sends multiple access collision detect. Now what is this all about? Let me just elaborate on this further. Carrier sends multiple access means, okay, all the devices, if I want to set up an Ethernet, typically you will find that all the devices are plugged in into some sort of a carrier. Now what is the carrier here? The carrier here would be the media through which I am carrying all the data. Okay, the Ethernet media when I talk about it, or the network cable when I talk about it, that is nothing but the carrier media. Okay, so this carrier media is able to take information about multiple devices together, right? Typically we connect a machine to a switch. That is what we do. So if you are connecting a machine to a switch, which means on the cable we have two devices. Do you see that? Okay, do you understand that? On a single cable, I have two devices plugged in, right? At one end we have a machine, and at the other end we have a switch. Okay, so that is why, okay, this carrier is able to sense multiple access of that carrier. Okay, now another major thing about the CSMA CD is, okay, even though it's a common carrier for both the devices, the moment, okay, it finds that there is a collision. I hope you understand this term, collision. Collision means, okay, the two devices try to send data together to each other, towards each other. What will happen is the data will collide with each other. Okay, if two devices are trying to communicate with each other simultaneously or at the same point of time, what's going to happen there? There is going to be a collision. So what's effectively going to happen is, on the Ethernet, the moment, okay, there is a collision, it's going to inform each and every device connected to that Ethernet about the collision, or it's going to know about that collision, and then all the devices are going to stop communication for a random amount of time. You understand? Okay. So in the case of CSMA CD, what's going to happen is, all the devices are connected to a common Ethernet, right? A common media. But then the moment there is a collision, all the devices would stop sending data or receiving data. They would stop, and then after a random interval of time, they are again going to start communication. Again, before starting communication, they'll check whether there is a collision. If there is a collision, again they'll stop for a random amount of time, and then they'll start communicating. You understand that? Clear about that? Okay, so that is what is CSMA CD. Do you understand the concept of CSMA CD? Come again? I didn't understand you. No, I didn't get your question. Can you come again? Okay. If collision happens, in fact, both the devices or all the devices on the Ethernet are going to stop the communication. Not just one device. Every device will stop the communication. You understand that? Okay, do you get that now? So whenever there is a collision, the devices are going to randomly stop the communication for a random amount of time. Well, they won't start at the same time. They'll start off again, communication again, after a random amount of time. Okay, so the time is not fixed. After a random amount of time, the devices will start sending traffic again. Again, if they find a collision, again they'll stop. Okay, so that's how they work. So effectively, they can have the capability of detecting a collision. You understand that? Okay. Okay, so this kind of a communication, when I talk about it, or CSMA CD communication which I talk about, is called as half duplex. Okay, so this kind of a communication of CSMA CD is also called as half duplex. Now, what do I mean by half duplex? Okay, half duplex means, okay, on the Ethernet, only one device, or whenever we talk about a single device, it can either send or receive data in a particular amount of time or in a particular time instance. Okay, again let me repeat that. Whenever we talk about half duplex means, okay, a single device can either send data or receive data on the media, okay, at a particular time instance. You understand? It cannot send and receive together. It will either send or receive. That is the meaning of half duplex. You understand that? Okay, and that is why I said they wait for a random interval of time before sending the data, or before starting the communication. So bottom line is, this will bring about longer chances or higher chances for collision. And typically, if you are making use of a hub, now when I talk about hub as a device, nowadays you do not find hub anywhere. But whenever we make use of hub anywhere on the network, okay, so hub is a layer 1 device. Remember that. Hub is not like a layer 2 device, it is a layer 1 device. So a hub typically works on half duplex communication. You understand? So if you are communicating or connecting all your computers or all the devices to a hub, which means you are getting half duplex communication. Understood? Okay. But then if we make use of a switch, like we don't make use of a hub, let's say, if we make use of a switch, in that case it is called as full duplex, or a switch supports full duplex. What does that mean? It means that you can send as well as receive data at the same point of time. Okay, so at the same point of time you can send data as well as receive data. That is what you can achieve with full duplex. Do you understand that now? Okay, which means that since it is full duplex, then there is no question of CSMA CD or collision detection or anything of that sort. So effectively you are avoiding collision if you are making use of a switch. You understand that now? That's what we talked about in our previous sessions also, right? When we talk about a switch, depending upon the number of ports, it creates separate collision domains. So bottom line is, everyone is not affected by the collision, or in general, collision is avoided. You understand that? So that's the reason we say when we make use of a switch, it provides you with full duplex communication. That means it can send as well as receive information at the same point of time. Understood now? Okay. So let's talk about how to set up the duplex option or the speed option on an interface. Okay, so whenever we talk about an interface, okay, be it that of a router or be it of a switch, we have the option of defining the duplex settings and the speed options. Okay, so let's first talk about how to set the duplex settings. Okay, now before we get on into talking about the duplex options or the speed options, one of the main things that you need to understand with regards to the duplex and the speed setting is, whenever we talk about the device, okay, if you go into the device now in the command line, okay, for an interface, okay, like when I type show interface fast Ethernet 0/1, let's say we do that. Okay, when we do that, do you see that here for this interface it's showing that it is full duplex, and then look at the speed. It's saying that the speed of this particular interface is 100 megabits per second. Okay, so bottom line is, as you notice, the duplex settings and the speed settings are already there. Okay, but by default for a switch or for a router on every interface, okay, for a switch or for a router on every interface, the duplex as well as the speed setting is set to auto. Okay, let me repeat that again for you. By default on a switch or on a router, the duplex and the speed setting are by default set to auto. What do I mean by that? Auto means, okay, the switch or the router is going to negotiate with the device at the other end about the status of duplex or speed. Okay, it's going to automatically negotiate and then it's going to set the value for it. Okay, we need not set the value. the device itself is going to auto negotiate and derive a value. That is what I mean by auto. So remember, by default the duplex and the speed setting is set to auto. You understand that? Okay, but if you want to manually set the duplex and speed setting, you have to go into the global configuration mode of the switch, get into the interface, okay, by typing in interface and the interface ID, okay, and then you have the option of typing in duplex. Either you can type auto or duplex full or duplex half. You understand that? Okay, so on an interface, okay, you can go into an interface and type in duplex auto or duplex full or duplex half. You understand that? These are the options that are available out here. Clear about that? Okay, let me show it to you on packet tracer. So if I go into the switch right now, okay, and on the switch I'll type configure terminal. This will take me into the global configuration mode, okay, and then I'll type in interface fast Ethernet 0/1. Okay, so I'll go into that appropriate interface where that device is plugged in, and then when I type duplex and then question mark, what do you notice? You see all the three options that are available: auto, full or half. Okay, so right now let's say for example I change the duplex settings to half. The moment I change the duplex settings to half, you find that the interface went down and then it came up. You see that? The interface went down and then it came up, and on the switch you find that again it is amber, right? Do you notice that? Again it shows that it is amber. You understand? Okay. Similarly, in a similar manner, just like the duplex setting, you can also type in speed, and then when I put question mark, by default remember it is auto, but then you have the option of defining 10. 10 means 10 megabits per second. 100 means 100 megabits per second. And if it's a newer series of 2960, then in that case you would also find 1000, that is 1 Gbps also available to you. Do you understand? So you have all of these speed options available, but by default remember the speed and duplex settings are set to auto. Do you understand that? Clear about this now? Okay, so understood about the speed and duplex settings. Okay. Okay, so that is how you can set the speed and duplex settings. Okay. Now to see the speed and duplex settings, like I told you, you have to type show interfaces and the interface ID. That will clearly tell you about the duplex setting as well as the speed on that particular interface. Okay. Now the next portion that I'm going to talk about is the different types of cables that you can have, or the different types of network media or Ethernet media that you can have. Okay, so let's talk about that. So for that part I'm going to open up packet tracer because I do not have a slide for that. You know, I've kept it separately so that you understand what I mean by this particular portion. Okay, so this portion I'm going to show it to you out here. Okay, so whenever I talk about a UTP cable, okay, if you remember, whenever we talk about Ethernet cable or the Ethernet copper cable, it's also called as UTP cable or unshielded twisted pair. Okay, so whenever I talk about unshielded twisted pair, there are two types of cable available. Okay, one of the copper cable that is available is straight through. Okay, one other type of copper cable that we can have is straight through. Okay, now typically whenever you look at a UTP cable, okay, and if you open up the outer shield, the outer PVC or the plastic coating that you have, once you remove that, what you find is there are 8 wires inside it. Okay, a typical copper cable or a typical UTP cable will have 8 wires inside it. Okay, in fact, let me just show you a diagram to you. So I'll go into images.google.com. Okay, so once I go there, I'll type UTP cable. Okay, so as you notice in this example here, in this diagram here, let me just open up this diagram. Okay, so what you find in this diagram is, these are the different wires that you see here, and forget about this portion. That is nothing but a plastic piece that is given so that these wires stay in place. I mean, do not go haywire. Just for those cable to be like thick. You have a thick plastic cord inside. So forget about that. But otherwise, what you would notice is there are 4 pair of cables that are available out here. Okay, each of the pair would be this first pair which you see here. One of the cable would be blue in color, and the other wire that you see in this twist would be a combination of blue and white. Okay, so you find blue as one wire, and the other wire would be blue white, a combination of blue white. You understand that? Okay, the second pair that you would find would be orange and orange white. Okay, then you have this particular separator, that's the thick wire which I talked about. Okay, it's not really for connection, it is only for the thickness of the cable. And then we have the third pair, that is green and green white. Okay, and the fourth pair that you find is brown and brown white. Okay, so typically these are the kind of wires that you would find. Okay, so each pair is twisted, that is why it's called as twisted pair. You understand? So the first pair that you would find is blue and blue white, orange and orange white, green and green white, and brown brown white. So effectively within a single cable you would have 8 wires. Do you agree with that now? Okay, a single cable will have 8 wires inside it. Okay, so if I talk about these 8 wires, okay, in fact let me just show a different diagram to you. Okay, so typically these wires have to be crimped using a crimping tool, and they have to be crimped into the RJ45 connector. That is what we discussed about yesterday, right? Okay, so once you crimp the cable, like this crimping has to be dependent or different for a straight through cable. Okay, so what happens in a straight through cable is the cables or the wires are placed one to one as in, okay, as you notice here, each wire out here, the position of each and every wire at both ends would be the same. Like the first cable that you see or the first wire that you see in this section is green white, and same thing you find at the other end also. Second wire that you see here is green, so even at the other end you find that is green. Next you find it as orange white. Okay, here also you find it as orange white. Then you have blue, here also you find it as blue. Then you have blue white, again here also you find it as blue white. Then you have orange, here also you find it as orange. Then you have brown white, here also you find it as brown white. And then you have brown, here also you find it as brown. So bottom line is each and every wire is using the same position at both ends. So it's a one to one connection. Okay, so that one to one connection is nothing but the straight through cable. Okay, so whenever I talk about a straight through cable would be using one to one wiring. You understand that? Okay, the wire at one end will be in the same position even at the other end. That is what is called as a straight through cable. Are we clear about the straight through cable? Okay, but then now what we'll talk about is where would you use a straight through cable? For which kind of connections will you use a straight through cable? A straight through cable typically would be used for connecting Okay, it is used for connecting two dissimilar devices. Okay, a straight through cable is used for connecting two dissimilar devices. Now what do I mean by dissimilar devices? Okay, like if you want to connect a PC to a switch, they are two different devices, right? So if you want to connect two different devices or two separate devices, that's where you would make use of a straight through cable. Okay, so in that case, if you want to connect a PC to a switch, or if you want to connect a router to a switch, that's where you would make use of straight through cable. You understand that? Clear about that now? Okay, so straight through cable would be used for connecting two dissimilar devices or two different devices. Okay, so let me put up the example also. So example would be PC to switch or laptop to switch or switch to router. Okay, so here we are going to use straight through cable, and understood how a straight through cable will work. Okay, so that is one type of a UTP cable that we can have. Okay, another kind of a UTP cable that we can have is cross over cable. Okay, so another kind of a cable that you can have, a UTP cable that you can have, is crossover. Okay, now what is this crossover? Okay, well, in the case of crossover, we do not have the concept of one-to-one wiring like what we had for straight through. In the case of crossover, okay, wire number 1. Okay, in the case of crossover, wire number 1 goes to wire number 3, and wire number 2 goes to position number 6 at the other end. Okay, let me repeat that again. Okay, wire number 1 at the first end will go into position number 3 at the other end. Wire number 2 at one end will go to position number 6 at the other end. You understand? Similarly, okay, similarly, when I talk about wire number 3 here, okay, wire number 3 here at one end will go to position number 1 at the other end. Okay, so you'll have a small kind of a twisting within the wires. Okay, and that is what is called as crossover. So wire number 1 goes to position number 3 at the other end, and wire number 2 goes to position number 6 at the other end. That is the concept of crossover cable. Okay, in fact, let me show you a diagram to make you understand of how a crossover cable would look like. Okay, now as you see here, that is the crossover cable that I mentioned before. Okay, so wire number 1 is going into position number 3, wire number 2 is going to position number 6, wire number 3 is going to position number 1. Okay, now ideally this 4 and 4 other wires should remain at the same position, but here, okay, it is being twisted there also. But ideally it should not. Okay, 4 and 5 remain at the same position, but here they are twisting it. So let me just take the correct example. Okay, in fact that diagram was not exact, so that's why I'll not choose that particular example. In fact, yes, this would be the correct version of it. Okay, so this would be the correct example of a crossover cable. As you notice here, wire number 1 goes to position number 3, wire number 2 goes to position number 6, wire number 3 goes to position number 1, and wire number 4, 5 remain as it is, 6 goes back to 2, and then 7 and 8 remain as it is. Okay, so that is an example of a crossover cable. You understand that? Clear? So that's the kind of cabling that you do with regards to crossover cable. But in the case of straight through cable, it is 1 to 1. 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4, 5 goes to 5, 6 goes to 6, 7 goes to 7, and 8 goes to 8. That is the concept of straight through. But that is used for connecting dissimilar devices. But when I talk about crossover, 1 goes to 3, 2 goes to 6. That is how you would remember it. You understand that? Okay. So now let's talk about where would you use the crossover cable. Okay, so let's talk about where would you use the crossover cable. Well, typically whenever I talk about the crossover cable is used to connect similar devices. Okay, so it is used to connect similar devices. Now what do I mean by similar devices? If I want to connect one PC to another directly using a cable, I would use a crossover cable. You understand? So if one PC needs to connect to another PC, then I would use a crossover cable. Okay. If one switch needs to be connected to another switch, there also I would use crossover cable. If one router needs to connect to another router directly, there also I would use crossover cable. So remember this, if I want to connect the same devices with each other, in that case I would make use of crossover cable. Do you understand? And the crossover cable would be in this fashion. Okay, but then there is a slight exception to this. In certain cases, okay, a crossover cable can also be used to connect a PC to a router. You know, if I want to connect a PC to a router, I can make use of a crossover cable. That is just the only exception that you would find. But otherwise, a crossover cable is used to connect similar devices. Okay, like switch to switch, or PC to PC, or router to router. You understand? So everywhere else it is the same device, but there is one exception to it, that is if you want to connect a PC directly to a router interface, in that case you would make use of a crossover cable. So understood that? Clear about this now? Okay, so these are the different types of media that you can make use of, either copper straight through or copper crossover. Okay, now let me show you an example to make you understand this very perfectly. Okay, in fact let me just delete the connection here. Okay, now at this point I want to connect a PC to the switch. So what kind of a cable do I need to make use of here for connecting the PC to the switch? What kind of a cable do you need to connect a PC to the switch? Yeah, you would need a straight through cable. That's right, absolutely right. Okay, so now what I'm going to do is, like, see, for connecting them I would go into connection. Now that's the copper straight through cable. If you can see my mouse pointer, okay, that is the copper straight through cable. But what I'm going to do is out here, okay, on purpose, okay, what I'm going to choose is I'm going to choose the copper crossover cable. Okay, let's see what happens with that. Okay, so I'll take a copper crossover cable and try to connect the PC at one end, and at the other end I'll try to connect the switch. Let's see what happens. Okay, so when I do that, what do you see? Both the lights are red. Do you see that? Both the lights at both ends show red. What does that mean? It means that they are not able to communicate with each other. Okay, so even the lights can be an indication of whether the cable is a problem or there is something wrong with regards to the communication. Okay, so it's very much important for you to have a look at the interface lights. You know, in fact, even if you look at your laptop right now, if it's connected via, let's say, a cable, you would notice that there is some light glowing on that LAN card. Okay, so the light is glowing means everything is fine, but if the light is not proper, if it's not green, if it is amber or orange all the time, which means something is wrong with that interface or something is wrong with the communication. Okay, so that's something that you have to always watch out for. So here, as you notice, even though I have a connection between, or even though I have a cable between the PC and the switch, it's red. Why? It's red because here we know that it's because it's a crossover cable. Do you understand that? Let me remove that. And now let me try to add a copper straight through cable. Okay, so from the PC I'll connect the switch. Now the moment I do that, see, for the straight through cable you find that it is good. You understand that? Okay, now what I'll do is I'll take another PC out here, and now I'll take a router. Let's say I take this particular router here, and I'm trying to connect this PC to the router. Let's see what happens. Okay, as I told you, a PC to a router typically has to be connected via a crossover cable, right? That's what I told you. That's an exception, right? Let's try to check that. Okay, what we are going to do is we are going to try to connect a PC to a router with a straight through cable first. Okay, because ideally, according to the concept of straight through, what does it mean? It is for connecting two dissimilar devices, right? And a PC and a router are two dissimilar devices. So let's try to connect them. So let's try to take the straight through cable here, connect one end of the PC to the router. Okay, now when I do that, what do you find? The light on the PC as well as the light on the router is red. Do you understand that? Okay, that's what you see when I add a cross straight through cable. Okay, now what I'll do is I'll remove this cable from here. Okay, and then I'll add a crossover cable. Okay, now what do you find? Even though I do that, what do you notice? It's still red. Okay, now why is it red here? It's not because of the cable. It's because whenever I talk about a router, by default all the interfaces of the router are shut down. They are not enabled. But when I talk about a switch, okay, on a switch all the ports are by default enabled, but on a router all the ports are shut down. Do you understand that? Okay, that's the reason it's showing red here. Okay, so what I'll quickly do is I'll go into this particular router. Of course, I've not taught you the command line of the router, but what I'm going to do is I'm going to go into the interface, configure terminal, just like the switch. I'll just go into the interface, that is interface F0/0, that is fast Ethernet 0/0, and I'll put no shutdown, just like what I taught you on the switch. Okay, so I'm putting up no shutdown here. So just because I put no shutdown, as you notice, now it has turned green. Do you understand that? So on a router, by default the ports are shut down. That's the reason it was showing red. But then the moment I enable them, it shows green. Now what I'll do is I'll remove this connection from here, and instead of a crossover cable, I'll try to add a straight through cable, and then we'll see what happens. Okay, so when I add a straight through cable, as you notice, even though the port is on or even though the port has been enabled, you notice that it is red or it is down. You understand that? Okay, so that's something that you have to be very careful about when you're choosing the appropriate cable. Okay, so that's the reason whenever you're setting up a network physically, okay, and if somebody gives you a bunch of cables, the first thing you have to look out for is what kind of a cable it is. Is it the right kind of a cable that you need? That means you have to check whether it is straight cable or cross cable, and for that I already gave you the method. If it is 1-to-1 wiring, which means it is straight through, but if it is 1-to-3 and 2-to-6, which means it is cross. Do you understand that? Clear about that now? Okay, so let's continue now. So now we are moving on to the last portion of this topic, wherein we are going to talk about troubleshooting common switch media issues. Okay, in fact, a part of this particular topic I have already covered it using the demonstration that I gave you about the cables. You know, a part of it I covered, but the remaining part is what we are going to cover now. Do you understand? So when it comes to checking whether communication is good, the common commands that you can typically make use of for testing communication is ping and the name, or ping and the IP address. Okay, so that is what you can typically do. Okay, you can ping using a name or ping using an IP address. When you do that, when you get replies, which means everything is fine. But if you do not get replies, instead of a reply, if you get request timed out, which means something is wrong. Do you understand that? Okay, again let me repeat. When you make use of the ping command, okay, if you are pinging using name, or you can ping using an IP address also, but whenever you do the ping, if you are getting the replies, which means everything is fine. But if you are not getting replies, instead of the reply, if you are getting request timed out, which means something is wrong with regards to the communication. You understand that? Okay. Now there are some other tools also available for testing purposes. One of them is ARP. ARP is nothing but address resolution protocol, but we are going to talk about this ARP table at a later stage. But remember this command here. On a Windows machine, if you go into the command prompt and type ARP-A, and inside ARP-A, if you see this kind of an output, which means things are fine. Okay, but remember we are going to talk more about this when we get to the next module. Okay, so even this is one tool by which we can check whether things are good. Another tool that is available is tracert. Okay, so you need to go into the Windows machine and type tracert, and then either you can type the name or you can type the IP address. So in that case, if you're getting replies in this manner, which means things are good. But if you're not getting replies, which means something is wrong. You understand that? Okay, so we talked about three tools now: ping, ARP, and tracert. Okay, so these are some tools by which you can test whether communication is good. Another tool that we have is Telnet, and again we are going to talk about Telnet at a later stage. In fact, all of these tools which I just talked about right now, we are going to talk about it or elaborate on these tools further once we learn about IP address. Okay, so that would be later. But for now, since we are talking about troubleshooting, these are some tools which you can make use of for troubleshooting purposes. You understand that? Okay. Now let's talk about the media issues which we were actually supposed to talk about. So let's first talk about media issues related to copper. Okay, so whenever we talk about copper media issues, they can have several reasons behind it. Okay, whenever I talk about copper media issues, the reasons can be the wire itself is damaged. That can be one of the reasons. Like, you know, a common problem that India faces in all of its networks is rats. You know, rat, right? A mouse. It can eat up the wire or chew up the wire. Okay, so that can be one of the problems that commonly Indian networks face. Okay, so that can be one of the things where the wire gets damaged. Okay, or another problem that can happen with regards to copper wire is electromagnetic interference. Okay, now as a networking best practice, it is always a good idea to have at least a spacing of nearly 2 feet. Okay, a spacing of nearly 2 feet should be placed between a network cable and the power cable. Okay, so you should never have a power cable and a network cable running side by side. You should separate them at least by a distance of 2 feet. That's the best practice. Why? Because then you are avoiding electromagnetic interference. Okay, so that can also be a problem when it comes to communication issues. You understand? Or some sort of a traffic pattern change. You know, you're finding a lot of broadcast on the internet, Ethernet. Okay, so when you find a lot of broadcast, you would not have enough bandwidth for your regular communication, due to which the machines are not able to talk to each other, or the devices are not able to communicate with each other. Or it might also happen that the devices are not configured properly. That can be also another problem. Like the cable that you're using may be faulty. That is, instead of a straight cable, you may have a cross cable, or instead of a cross cable, you may be using a straight cable, or the crimping may be faulty. You might not have crimped it properly. That is, you might not set up the cable properly. That can be another reason why it can bring about a media issue. You understand that? Whenever we talk about fiber, okay, that is fiber optic cable. Okay, when it comes to fiber optic cable, one of the major things that related to fiber optic is macro bend losses. Now, what is macro bend losses? Okay, now see, whenever we talk about a copper wire can be bent to any extent. Okay, a copper wire can be bent to any extent. Okay, can you give me a moment? Just give me a moment. Yeah. Okay, so let's continue. Okay, so as I was saying, whenever we talk about a copper wire can be bent to any extent. But when we talk about a fiber, okay, a fiber optic cable should be bent only to a particular radius. Okay, if you bend more than that, and if the radius is reduced to a very small size, what is going to happen then? In that case, the light which is transmitted to the fiber optic may escape, due to which it can cause communication issues. Okay, so bottom line is, when it comes to fiber optic cable, you cannot bend it to a very large extent. You can bend it to a certain extent. You understand that? Okay, so remember that. So bending of the fiber optic cable, you can only do it to a certain extent. Okay, so the radius has to be maintained to a particular value. If it goes lower than that particular value, then the media will cause issues. Okay, and another problem with regards to fiber optic is splicing losses. Now, what is splice loss? Splice loss is nothing but, if at all the fiber cable itself is damaged, okay, it can cause issues with regards to communication. Okay, now going ahead, so whenever we talk about troubleshooting with regards to switches, okay, one of the things that you need to understand is switches operate at layer 2 of the OSI model. Okay, so bottom line is, they are devices which connect to other devices using the physical media. Okay, so most of the problems related to media would be either at layer 1 or it can be at layer 2. Okay, layer 3, that is the network layer, issues can arise with regards to that only when the management configuration or the IP address configuration on the switch is not set up properly. Remember that. Okay, so whenever we talk about issues, most of the network issues might arise at layer 1, that is the cable issue, or it can be a layer 2, that is the MAC address issue, okay, or the switch issue. But layer 3 issues can be more related to the IP address. Okay, understood this part? Okay, now whenever we talk about switched media issues, again, most of the reasons can be wire gets damaged, or there can be EMI sources, that is electromagnetic interference, or traffic patterns change, or new equipment is installed, or faulty cable. You know, these can be several causes, the same things which we discussed before. Okay, but getting along, okay, these are some commands by which you can check whether some errors or there are some issues with regards to that. Okay, so show interface and the interface ID. When you do that, you can have a look at the duplex setting and the speed setting. That is one of the things that you can check. Apart from that, you can check whether there are any input errors or output errors shown. So if you find there are some input errors or output errors, which means something is wrong. Do you understand that? So you are supposed to look out for these options here. Do you understand? Apart from that, you can also check for excessive noise or excessive interference. Okay, so another term for excessive noise is excessive interference. So if at all you have a lot of collisions on the network, okay, in that case also you can have a lot of interference. Okay, so remember that. So you have to look out for the show interface command. So when you look out for the show interface command, it will tell you about whether there are any errors or whether there is any sort of excessive collision or there is some sort of a disturbance on the LAN. You can also inspect the cables for damage. Okay, and if you are using a Cat5, see to it that it is crimped properly. Okay, so these are certain things that you need to look out for. Excessive noise means excessive interference or excessive collision. Okay, so all that is collectively called as excessive noise. You understand that? Okay. Okay, so remember that whenever we have excessive collisions, That's the command that you're supposed to look out for, show interface. That will tell you about the losses or errors that might be happening with regards to the interface. Okay. Now, you can also make use of a protocol analyzer software. Another name that is given to the protocol analyzer software is sniffer. Okay. Now, what is a sniffer? Sniffer is a tool which can be used on the LAN to check out for network traffic. Okay, so if you are looking out, or this kind of a software can look out for network traffic, and it can also give you indications of whether there is a collision. Okay, in fact, I'll give you a simpler way of doing it. You can also look out for the light on the network card. If you find the light on the network card is blinking violently, that is, it's like a fast blinking. Okay, so if it is like a fast blinking, which means something is wrong with regards to the LAN. Okay, so either on the network card or even on a switch or on a router, if on the interface you find that there is a fast blinking, which means something is wrong on the LAN. Okay, which means it can be a cable issue, or there can be excessive collision, or there can be excessive noise on the network. You understand that? So these are some common indications by which you can check whether there is a fault. Okay. Now, port access issue can be another problem that you might face. Okay, the port access issue is nothing but the switch port is not coming up. So if the switch port is not coming up, it can be either related to a media issue, which is what we talked about. If you are using a wrong cable, that can be one of the things, or it can be a duplex or a speed related issue. Like if the duplex setting or the speed setting is not set properly, that is also a case wherein you would find that the switch port is not coming up. Do you understand that? Okay. So when it comes to duplex mode, okay, as I told you before, by default the duplex mode is set to auto. Okay, so typically since the duplex mode is set to auto, the device will try to negotiate the duplex setting automatically. But if the device fails the negotiation, if it is not able to negotiate with the other device, okay, typically on a switch you would find that a lot of messages start popping up indicating that duplex mismatch. You would find a message like duplex mismatch coming up on the switch. So if you find a message like a duplex mismatch coming in on the switch, which means, okay, there is some problem with regards to the duplex setting. Do you understand that? Okay, so if at all you want to troubleshoot any issue with regards to something, always look out for these kind of messages. So on a switch, if you come across a message which states duplex mismatch, which means something is wrong with regards to the duplex setting. Do you understand that? Okay. So remember, the duplex settings have to match at both ends. So if the duplex setting is not matching at both ends, that's when you would find a duplex mismatch. You get that? Okay. Remember this. Okay. So for troubleshooting, this could be one good indication. Okay. Speed also can be an issue. Okay. Like if the speed at both ends is different, that can result in a speed mismatch. Do you understand? So if at all you come across a duplex mismatch or a speed mismatch, which means you have to automatically check for the duplex setting and the speed setting. Okay. Now, okay, it can also happen that, like at both ends it is set to auto, but the devices are failing the negotiation. In that case also you would get a speed or a duplex mismatch. Okay, so in that case also you have to go ahead into the devices and set the speed and duplex settings manually. You'll have to change it from auto and set the values manually. Okay, so that is what you have to do. Okay, so typically when it comes to configurational issues, what you have to do is you have to know what is the existing configuration on the individual devices before you start troubleshooting. That's the main thing about it. Okay, so before you start troubleshooting, you always have to know the current network. Without knowing the current network, it is very difficult to troubleshoot any sort of issue. Okay, so you have to have a hard copy of the configuration. That can be one of the things that you can have, or you can have the configuration in the form of a text file, or you can keep a backup of the configuration on TFTP server. Okay. Then whenever you're troubleshooting some issue, see to it that after you put up some changes, see to it that the issue has been solved. If not, then you have to change the configuration. Okay, that would be one of the things that you would do. Okay. After solving the issue, you have to also see to it that you're saving the configuration. Now, how would you save the configuration? You would save the configuration using the copy running config startup config. Okay, so that is what you have to do. Okay, and then as a typical configurational thing, you have to secure the configuration by putting up password protection for the console, or you have to put up password protection for the BTY, that is the telnet session, or you have to put up password protection for the exec mode. Now I'll be talking about all these commands at a later stage, but that is a good practice or a best practice when it comes to configurational issues. Okay. So that was the topic which we had. Okay, but now what you need to really do is I'll be giving you 2 labs to work over the weekend. Okay, so over the weekend I'm going to give you 2 labs. Okay, one is lab 1-1 and the other one is lab 1-2. Let me just show you those 2 labs. Okay, so I'm going to give you both of these files. Okay, you have to just double click on the file and open it. I mean, you have to download these files onto your computer and just double click on these files. So when you do that, it will automatically open it up into Packet Tracer. Let me just show that to you quickly. Okay, let me just show that to you quickly. Yeah, so when you open up the file, you know, that is what it's going to show you. It's going to show you the topology as well as it's going to show you the activity of what you're supposed to perform. So you're supposed to double click on the appropriate device and then you're supposed to follow these activities. You understand? Okay, so that's how you're supposed to do the lab. So now the next session that we would have would be after the weekend. Okay, so on Monday. So on Monday or over the weekend, what I would need from you is you have to go through this particular thing. You know, you have to do both of these labs and you have to give me the solution. You understand? Okay, so you have to go through both of these labs and you have to give me the solution. You understand? Okay, so you can give me the solutions via email, but that's the main thing. Okay, so I'll send you both of the files, and then you can give me the solutions back via email. I'll give you like if you're stuck up with that, you can always write to me via email, and then we can troubleshoot it, or I can give you the responses accordingly. Okay, so remember this: these 2 labs you're supposed to complete it over the weekend, and before the start of the next session, see to it that you complete the lab and give me the solution for it. You understand that? Okay. Okay, so I hope the session was informative, and we are going to now meet up after the weekend on Monday. Okay, so have a nice weekend and see you in the next session. Okay.